Hello Primary 3. In this video we're going to talk about the area. The area of a compound shapes. If I have this array and I know the area of this array is number of row by number of columns, so I multiply here the number of row by number of column. How many row we have here? 1, 2, 3, 4. How many columns? 1, 2, 3, 4, 5, 6. So the area of this array is 4 multiply 6 will be 24 square unit. Look here, if I cut this array into two parts, into two small arrays, and I want to find the area of this one and this one. Let's see, the area of this one is number of row by number of column, 1, 2, 3, 4, and how many columns? 1, 2, 3, 4, so it's 4 by 4. What about the area of this one? Is 1, 2, 3, 4 by 1, 2. Number of row by number of columns, it's 4 by 2. So if I want to know the area of them together, let's add it together. 4 by 4 plus 2 by 4. Sorry, plus 4 by 2. 4 by 4 equals 16 and 4 by 2 equals 8. If I add them together, it will give me 24. So this means if I cut a whole big array into two small arrays, they together, the area of them together will give me the area of the bigger one. And I can deduce something else. As you can see here, 4 by 6 give you 24. And 4 by 4 plus 4 by 2 give you 24. So they are together give you the same answer of 4 by 6. So I can deduce that 4 by 6 will be 4 by 4 plus 4 by 2. It means if I keep the first factor as it is and cut the second factor that we have here is 6. If I cut it, okay, into two parts, or I decompose it into two parts, 4 and 2, it will give you the same answer. Again, I have here 4 by 6. If I keep 4 like it is, like you can see here, and decompose 6 into 4 and 2, or any two numbers, decompose the second factors into two numbers, it will give you the same product if you add them together. Because I have here a whole area and I cut it into two parts, and this two parts is the same of the bigger one, so it will give you the same product. Okay, let's test if what we just said is true or not. I have this big array and I cut it into two small arrays, and I find the area of this big array and this small arrays, and let's see if it's equals or not. So the area is number of row by number of column. Let's count here how many row we have. 1, 2, 3. How many columns we have? 1, 2, 3, 4, 5, 6, 7. So the area is 3 by 7. 3 by 7 give you 21. Okay, now I got the area of the big one. Let's get the area of this one after I cut them. After I cut this big array into two small ones, let's find the area of them. The area is row by column, so 1, 2, 3 by 1, 2, 3, 4, so it's 3 by 4. This is the area of the first part. The other part is 1, 2, 3 by 1, 2, 3, so it's 3 by 3. This is the area of the other part, 9. So I want them all together. All together means I'm going to add them. So I will add 12 plus 9. It will give me 21. So as you can see, I have here 21 square unit and here 21 square units. So the both are equals. So again, if I cut a big array into two small parts, two small arrays, So their area will equal to the area of the big one if I add them together. And let's look here. I have here 3, as you can see, the first component or the first factor, okay, as it is. And the other factor I have is 7. This factor is cut into 4 and 3. I decompose it into 4 and 3. So I keep the first factor like it is, and I cut or decompose the second factor into 2 numbers. So 4 and 3 will give me the 7. So this means I will have the same product if I just decompose one factor and keep the other one. Okay, let's look at this one. 5 multiply 4. It will be 5 multiply 3 plus 5 multiply what? So as you can see, I keep the first component or the first factor like it is. And the second factor I have is 4. And I put here 3. And what is the rest of 4 here? 3 plus what gives you 4? 3 plus 1. So the missing component here, or the missing factor, is 1. The second number I have is 7 by 9, and 7 by 4 plus 7 by what? 7 is kept like it is, and 9 is decomposed into 4 and what? 4 plus what give you 9? 4 plus 5 will be 9. So look at the next one. 2 multiply 5 will be 2 multiply what? Plus 2 multiply 3. As you can see, the first factor like it is, it doesn't change. And the second factor is 5. I cut it into what? Plus 3. So 3 plus what will give you 5? 3 plus 2. So the missing factor here is 2. 4 multiply 3. So I kept 4 like it is all the time. And the second factor I have here is 3. So 3 is decomposing into 2 and what? 2 and 1. Okay, look at this one. This is you need to focus at this one. So 1 multiply what equal this. So the first component I have here is 1. Okay, as you can see, the first component of this is missing. Okay, not the second. And the second here is 2 and 3, and the second here is missing. So if I add 2 and 3 together, I get this one here. So 2 and 3 will be 5. And here 1 is the first component or the first factor, so I write it as it is here and here, 1 and 1. Again, and this question we have 1 multiply what will be what multiply 2 and what multiply 3. The first number I have here is 1. So I write it here as it is in the first component or the first factor. The second factor is the one that gets decomposed or the one that cutting. So I have here 2 and 3. If I add them both together, it will give me this factor. So 2 and 3 will be 5. Okay, 3 multiply 2 plus, as you can see, the sign of addition is here, not there. Okay, pay attention. 3 multiply 6 equals 3 multiply what? So the first factor I have here is 3, and we keep it like it is. The other factor 2 is and 6. So I add them both together will give me 8. And 5 multiply 3 plus 5 multiply 1. 5 is kept like it is. So I put here 5. And 3 and 1, I add them together to get this one. It will be 4. Don't forget, this is the equal sign and this is the plus sign. So this is a small array and this is a big one. Okay, the last one we have here. 8 plus 8 multiply 7. As you can see, I have only 8 here. What I can do. Okay, I know that 8 is equals to, this is the first component I have. So I will keep it like it is. And the other component, how I can find it, or the other factor, how I can find it. Okay, I know that 8 is equals to 8 multiply 1. So I will suppose that this is 8 multiply 1. And this is 1 I have here, and 7, so I will add them together. It will be 8. I want to find the whole area of these shapes. Okay, I only get to know the number of row and number of column, not what's inside of it. So you can deduce the number from the number of row and column the area, or you can continue the shape like this. Okay, and count the inner space. Count how many units you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12. Or I can just find number of row and number of column. I have 1, 2, 3, 4 row and 1, 2, 3 columns. So it's 3 row column and 4 rows. 3 by 4 equals 12. Here I can connect the shape, or I can just find the area from number of row and number of column. You can connect the shape like this, but please try to use your ruler to find it. Okay, connect the shape and count what's inside of it. Or I can find number of row by number of column. I have here 1, 2, 3, 4, 5 row and 1, 2, 3, 4. So it's 4 multiply 5 will be 20. So the area up here is 20. I can just write it not to count all of them. That's all. Thank you for listening.